Good morning, children. Welcome to the next part of Chapter 4, Heat, Part 4, Textbook Reading Practice. So far, we have done 2 video lessons, 4 worksheets, and a video on reader exercise. Today, we are going to read the lesson word by word and understand better. As you read, if you find any sentences, words important, you can underline or make a note, and when you get a textbook, you can underline the same and keep it for further reference. So let's join and read the lesson for heat. Lesson 4, Heat. In Chapter 3, you learned that woolen clothes are made from animal fibers. You also know that cotton clothes are made from plant fibers. We wear woolen clothes during winters when it is cold outside. Woolen clothes keep us warm. We prefer to wear light-colored cotton clothes when it is hot. These give us a feeling of coolness. You might have wondered why particular type of clothes are suitable for a particular season. In winter, you feel cold inside the house. If you come out in the sun, you feel warm. In summer, you feel hot even inside the house. How do we know whether an object is hot or cold? How do we find out how hot or cold an object is? In this chapter, we shall try to seek answers to some of these questions. (4.1) Hot and cold. In our day-to-day life, we come across a number of objects. Some of them are hot and some of them are cold. Tea is hot and ice is cold. List some objects you use commonly in table 4.1. Mark these objects as hot or cold. So we have a table here. Some objects, so you can add some more objects if you want. First one is done for you. Ice cream is cold. So you find out whether it is hot or cold. Okay. So spoon in tea cup. Tea is usually hot. So what will be the spoon? Spoon also will be hot, right? Fruit juice usually is cold, isn't it? We put ice cubes and drink our juice. Handle of a frying pan. So pan which is used for frying pan will be warm, isn't it? Hot, yes. Do not touch objects which are too hot. Be careful while handling a candle flame or a stove. We see that some objects are cold while some are hot. You also know that some objects are hotter than others, while some are colder than others. How do we decide which object is hotter than the other? We often do it by touching the objects. But is our sense of touch reliable? Let us find out. See the picture here, right? So this is mug A, this is mug B, this is mug C. Understand? Do both the hands get the same feeling? Bujo says, my left hand tells me that water in mug C is hot, and the right hand tells me that the same water is cold. What should I conclude? Bujo's confusion shows that we cannot always rely on our sense of touch. to decide whether an object is hot or cold. Sometimes it may deceive us. Then, how do we find out how hot an object really is? A, reli- a reliable measure of the hotness of an object is its temperature. Please underline. A reliable measure of the hotness of an object is its temperature. Here also please underline. Temperature is measured by a device called thermometer. 4.2 Measuring temperature. Have you seen a thermometer? Recall that when you or someone else in your family had fever, the temperature was measured by a thermometer. The thermometer that measures our body temperature is called the clinical thermometer. Please underline. The thermometer that measures our body temperature is called clinical thermometer. Hold the thermometer in your hand and examine it carefully. If you do not have a thermometer, request a friend to share it with you. A clinical thermometer looks like the one shown in figure 4.2. So this is a clinical thermometer. You can see how the calibrations are done here. A clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end. This bulb contains mercury. Outside the bulb, a small shining thread of mercury can be seen. If you do not see the mercury thread, rotate the thermometer a bit till you see it. You will also find a scale on the thermometer. The scale we use is the Celsius scale, indicated by degrees Celsius. A clinical thermometer reads temperature from 35 degrees Celsius to 42 degrees Celsius. Bujo wondered which of the two scales shown in figure 4.2 he should read. Peheli told him that India has adopted the Celsius scale and we should read that scale. The other scale with the range 94 to 108 degrees is the Fahrenheit scale, degree Fahrenheit. It was in use earlier. Activity 4.2 Reading a thermometer. Let us learn how to read a thermometer. First, note the temperature difference indicated between the two bigger marks. Also, note down the number of divisions shown by a smaller marks between these marks. Suppose the bigger marks read 1 degree and there are 5 divisions between them, then one small division can read 1 by 5, which is equal to 0.2 degrees Celsius. Wash the thermometer, preferably with an antiseptic solution. Hold it firmly and give it a few jerks. The jerks will bring the level of mercury down. Ensure that it falls below 35 degrees Celsius. Now, place the bulb of the thermometer under your tongue. After 1 minute, take the thermometer out and note the reading. This is your body temperature. The temperature should always be stated with its unit degrees Celsius. What did you record as your body temperature? The normal temperature of human body is 37 degrees Celsius. Note that the temperature is stated with its units. Peheli measured her body temperature. She got so worried as it was not exactly 37 degrees Celsius. Let us try to ensure Peheli that there is nothing wrong with her. Now, precautions to be observed during reading a clinical thermometer. Number 1. Thermometer should be washed before and after use, preferably with an antiseptic solution. Ensure that before use the mercury level is below 35 degrees Celsius. Read the thermometer keeping the level of mercury along the line of sight. Handle the thermometer with care. If it hits against some hard object, it can break. Don't hold the thermometer by the bulb while reading it. Activity 4.3. Measure the body temperature of some of your friends, at least 10, with, with a clinical thermometer. Record your observation as in table 4.2. So this is name and temperature. Now that you are all at home, you can measure the temperature of your family members, right? Is the body temperature of every person 37 degrees Celsius? The temperature of every person may not be 37 degrees Celsius. It could be slightly higher or slightly lower. Actually, what we call normal temperature is the average body temperature of a large number of healthy persons. The clinical thermometer is designed to measure the temperature of human body only. The temperature of human body normally does not go below 35 degrees Celsius or above 42 degrees Celsius. That is the reason that this thermometer has a range 35 degrees Celsius to 42 degrees Celsius. Bujo got a naughty idea. He wanted to measure the temperature of hot milk using a clinical thermometer. Peheli stopped him from doing so. Caution! Do not use a clinical thermometer for measuring the temperature of an object other than the human body. Also, avoid keeping the thermometer in the sun or near a flame. It may break. Different types of thermometers are used for different purposes. The maximum and minimum temperature of the previous day reported in weather reports are measured by a thermometer called the maximum minimum thermometer. 4.3 Laboratory thermometer. How do we measure the temperature of other objects? For this purpose, there are other thermometers. One such thermometer is known as laboratory thermometer. Teacher will show this. We have shown a laboratory thermometer in our video, right? Look at it carefully and note the highest and the lowest temperature it can measure. The range of laboratory thermometer is generally from minus 10 degrees Celsius to 110 degrees Celsius. It's given in the diagram. Also, as you did in the case of clinical thermometer, find out how much a small division on this thermometer reads. You would need this information to read the thermometer correctly. In addition to the precautions needed while reading a clinical thermometer, the laboratory thermometer should be kept upright, not tilted. Bulb should be surrounded from all sides by the substance of which the temperature is to be measured. The bulb should not touch the surface of the container. Activity 4.4 is the laboratory thermometer which we were studying about. Take some tap water in a beaker or a mug. Dip the thermometer in water so that the bulb is immersed in water. But does not touch the bottom or the sides of the container. Hold the thermometer vertically, like given in this picture. 4.5. Observe the movement of mercury in the thermometer. Wait till the mercury thread becomes steady. Know the reading. This is the temperature of water at that time. Compare the temperature of water recorded by each student in the class. So in the class, in the laboratory, we'll be doing actually. Bujo now understand why clinical thermometer cannot be used to measure high temperatures, but still wonders why a laboratory thermometer can be used to measure his body temperature. Are there any variation in these readings? Discuss the possible reasons. Let us try to answer this question. Activity 4.5. Take some hot water in a beaker or a mug. Dip the thermometer in water. Wait till the mercury thread becomes steady and note the temperature. Now take out the thermometer from the water. Observe carefully. What happens now? Do you notice that as soon as you take the thermometer out of the water, the level of the mercury begins to fall? This means that the temperature must be read while the thermometer is in water. You may recall that while taking your own temperature, you have to take the thermometer out of your mouth to note the reading. Can you then use the laboratory thermometer to measure your body temperature? Obviously, it is not convenient to use the laboratory thermometer for this purpose. Why does the mercury not fall or rise in a clinical thermometer when taken out of the mouth? Observe a clinical thermometer again. Do you see a king? Please underline this king word is very important. Near the bulb. So you can see a king, small king here. Yes. Do you see a king near the bulb? What is the use of the king? It prevents mercury level from falling on its own. Bujo wonders why the level of mercury should change at all when the bulb of the thermometer is brought in contact with another object. There is a lot of concern over the use of mercury in thermometers. Mercury is a toxic substance and it's very difficult to dispose of if a thermometer breaks. These days, digital thermometers are available which do not use mercury. 4.4 Transfer of heat. You might have observed that a frying pan becomes hot when kept on a flame. It is because the heat passes from the flame to the utensil. When the pan is removed from the fire, it slowly cools down. Why does it cool down? The heat is transferred from the pan to the surroundings. So you can understand that in both cases, the heat flows from a hotter object to a colder object. In fact, in all cases, heat flows from a hotter object to a colder object. How does heat flow? Let us investigate. Peheli asks, does it mean that heat will not be transferred if the temperature of two objects is the same? Activity 4.6. Take a rod or flat strip of a metal, say of aluminium or iron. Fix a small wax piece on the rod. This piece should be at nearly equal distances. Clamp the rod to the stand. If you do not find a stand, you can put one end of the rod in between two bricks. Now, heat the other end of the rod and observe. What happens to the wax pieces? Do these pieces begin to fall? Which pieces falls the first? Do you think that heat is transferred from the end nearest to the flame to the other end? Please underline. The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. Did you underline, children? In solids, generally, the heat is transferred by the process of conduction. So, in solids, it's mostly conduction. Do all substances conduct heat easily? You must have observed that metallic pan for cooking has a plastic or wooden handle. Can you lift a hot pan by holding it from the handle without getting hurt? Activity 4.7. Heat water in a small pan or beaker. Collect some articles such as steel spoon, plastic spoon, pencil, and dividers. Dip one end of each of these articles in the hot water. It's shown in the picture. Wait for few minutes. Touch the other end. Enter your observation. The material in table. So here you have to enter the steel spoon, plastic spoon, pencil, all this list. Then what material it is, whether it is made of metal or plastic or wood, you have to write. And does it get the other end gets hot? You have to write that observation here. The materials which allow heat to pass through them easily are conductors of heat. For example, aluminium, iron, and copper. The materials which do not allow heat to pass through them easily are poor conductors of heat, such as plastic and wood. Please underline. The whole paragraph is important. Poor conductors are known as insulators. The water and air are poor conductors of heat. Then, how does heat transform takes place in these substances? Let us find out. Activity 4.8. Take a round bottom flask. If flask is not available, a beaker can be used. Fill it 2/3 with water. Place it on a tripod. Tripod is a triangular structure with three hands like this. Okay. Or make some arrangement to place the flask in such a way that you can heat it by placing a candle below it. Wait till the water in the flask is still. Place a crystal of potassium permanganate at the bottom of the flask, gently using a straw. Now heat the water by placing the candle just below the crystal. Write your observation in your notebook and also draw a picture of what you observe. When water is heated, the water near the flame gets hot. Hot water rises up. Underline. The cold water from the sides move down towards the source of heat. This water also gets hot and rises. Very important. And water from the sides move down. The process continues till the whole water gets heated. This mode of heat transfer is called convection. Very important. Now, how does heat travel in air? In which direction does the smoke go? The air near the heat source gets hot and rises. The air from the sides come in to the the air from the sides come in to take its place. In this way, the air gets heated. The following activity confirms this idea. Activity 4.9. Light a candle. Keep one hand over the flame and one hand on the side of the flame. Do your hands feel equally hot? If not, which hand feels hotter and why? Be careful. Keep your hands at a safe distance from the flame so that they do not get burnt. Notice that towards the top the air gets heated by convection. Underline. Therefore, the hand above the flame feels hot. On the sides, however, there is no convection and the air does not feel as hot as the top. The people living in coastal areas experience an interesting phenomena during the day. The land gets heated faster than the water. Air, the air over the land becomes hotter and rises up. The cooler air from the sea rushes in towards the land to take its place. The warm air from the land moves towards the sea to complete the cycle. The air from the sea is called sea breeze. Please underline. To receive the cooler sea breeze, the windows of the houses in coastal areas are made to face the sea. At night, it is exactly the reverse. The water cools down more slowly than the land, so the cool air from the land moves towards the sea. This is called land breeze. Please underline, the whole paragraph is important. Figure 4.11 shows this phenomenon. Now we come out in the sun, we feel warm. How does the heat from the sun reach us? It cannot reach us by conduction or convection, as there is no medium such as air in most part of the space between the earth and the sun. From the sun, the heat comes to us by another process known as radiation. Underline. Transfer of heat by radiation does not require any medium. Please underline, very important. It can take place whether whether a medium is present or not. When we sit in front of a room heater, we get heat by this process. A hot utensil kept away from the flame cools down as it transfers heat to the surrounding by radiation. Our body too gives heat to the surrounding and receives heat from it by radiation. Please underline. All hot bodies radiate heat. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. Why are you advised to use an umbrella when you go out in the sun? So this is the picture of land and sea breeze. 4.5 Kinds of clothes we wear in summer and winter. You know that in summer we prefer light colored clothes and in winter we usually wear dark colored clothes. Why is it so? Let us find out. Activity 4.10. Take two identical tin cans. Paint the outer surface of one black and other white. Pour equal amounts of water in each and leave them in the midday sun for about an hour. Measure the temperature of water in both the cans. Do you find any difference in temperature? In which can is the water warmer? You can feel the difference even by touching the water in the two cans. We often use electricity and fuels like coal and wood to keep our houses cool and warm. Is it possible to construct buildings that are not affected much by heat and cold outside? This can be done by constructing outer walls of buildings so that they are trapped layers of air. One way of doing this is to use hollow blocks, which are available these days. Activity 4.11. Fill the two cans used in activity 4.10 with the same amount of hot water at the same temperature, say 60 degrees Celsius. Leave the cans in a room or in a shade. Note the temperature of water after 10 to 15 minutes. Does the temperature of water in both the cans fall at the same amount? Do these activities suggest to you the reason why it is more comfortable to wear white or light colored clothes in summer and dark colored clothes in winter? Underline, this can be asked for give reason questions. Dark surface absorb more heat and therefore we feel comfortable with dark colored clothes in the winter. Underline. Light colored clothes reflect most of the heat that falls on them and therefore we feel more comfortable wearing them in the summer. Please underline. Woolen clothes keep us warm in winter. In the winter, we use woolen clothes. Wool is a poor conductor of heat. Underline. Moreover, underline this also. There is air trapped in between the wool fibers. This air prevents the flow of heat from our body to the cold surroundings, so we feel warm. Suppose you are given the choice in winter of using either one thick blanket or two thin blankets joined together. What would you choose and why? Remember that there would be a layer of air in between the blanket. Now we'll just go through the keywords in this chapter. Keywords. You need to find the definition for these keywords. These questions will be asked under give the scientific term. Celsius scale, conduction, conductor, convection, insulator, land breeze, radiation, sea breeze, temperature, thermometer. So these are the important points what we have learnt. First one, temperature is a measure of degree of hotness of an object. Thermometer is a device used for measuring temperatures. Clinical thermometer is used to measure our body temperature. The range of this thermometer is from 35 degrees Celsius to 42 degrees Celsius. For other purposes, we use the laboratory thermometers. The range of these thermometers is usually from -10 degrees Celsius to 110 degrees Celsius. The normal temperature of the human body is 37 degrees Celsius. The heat flows from a body at a higher temperature to a body at lower temperature. There are three ways in which heat can flow from one object to another. These are conduction, convection, and radiation. In solids, generally, the heat is transferred by conduction. In liquids and gases, the heat is transferred by convection. No medium is required for transfer of heat by radiation. The materials which allow heat to pass through them easily are conductors of heat. The materials which do not allow heat to pass through them easily are called insulators. Dark colored objects absorb radiation better than the light colored objects. That is the reason we feel more comfortable in light colored clothes in the summer. Woolen clothes keep us warm during winter. It is so because wool is a poor conductor of heat and it has air trapped in between the fibers. Now this is extended learning and activities. So if you are interested, you can go through them and you can prepare the answers on your own. These are very interesting activities. You can try this project work also on your own. So this is a website that is given for further reading you can use. So far we have finished the reader reading practice. We have completed video lessons. We have finished the worksheets. We have finished the reader exercise. Now reader reading practice is also over. Now prepare well for the home test. This home test helps you to revise the lesson well. Understand? So get prepared for the home test. Read the lesson again, word by word, sentence by sentence, to understand better. Thank you, children.